Good morning, 8th graders. We are starting a new chapter in science. We are actually going to combine two lessons today, so we will not read the My Planet Diary. So we're going to go straight to our key questions here. Oops. We're starting a chapter on sound. So lesson 1 is the nature of sound, and lesson 2, the properties of sound. So key questions for lesson 1. What is sound and what factors affect the speed of sound? For lesson 2, what affects pitch, what affects loudness, and what causes the Doppler effect? So sound, I'm going to actually move down here. Sound is a disturbance that travels through a medium as a longitudinal wave. So we're kind of going to build off of our waves chapter from last time. So like other mechanical waves, sound waves carry energy through a medium without moving the particles of the medium along. Each particle of the medium vibrates as the disturbance passes. When the disturbance reaches your ears, you hear the sound. A common medium for sound is air, but sound can travel through solids and liquids too. For example, when you knock on a door, the sound goes from one side of the door to the other side so the people can hear it. Sound waves can diffract or bend around the edges of an opening, such as a doorway. So that's similar to mechanical waves from last chapter. We talked about how they can diffract and go and bend. Like other mechanical waves, in a sound wave, the particles in the medium are close together in a compression and farther apart in a rarefaction. I have to apologize to you because all last chapter I said this word with an extra R in it. So it is rarefaction, not rarefraction. Okay, I apologize for that. So, second question, the speed of sound depends on the temperature, stiffness, and density of the medium the sound travels through. So 3 things that the speed of sound depends on. So sound travels more slowly at lower temperatures than higher temperatures, and that's in a liquid or a gas. So if you would have, let's say, hot water, the sound would travel faster through that. Sound travels more quickly in stiff media, such as the ground, because when the particles of the medium are compressed, they quickly spread out again. Knocking on both a wooden and steel door, the sound would travel quicker from a steel door because it is more stiff than wood. And then solids are stiffer than liquids or gases. The particles are close together, so they bounce back and forth quickly as the compressions and rarefactions of the sound waves pass by. And sound generally travels the slowest in gases. And maybe if you think back to learning about solids, liquids, and gases, you remember that's because the particles in a gas are the furthest apart. Okay? So the last thing about lesson 1, density is our only vocabulary word for lesson 1. So density is how much matter or mass there is in a given amount of space or volume. The more dense the material, the more mass it has in a given volume. In denser materials, it is harder for the particles to move as sound waves pass by, and this slows sound down. So, lesson 2, the properties of sound. We have pitch, which is a description of how a sound is perceived as high or low. The pitch of a sound you hear depends on the frequency of the sound wave. Sound waves with a high frequency have a high pitch. Sound waves with a low frequency have a low pitch. Loudness describes your awareness of the energy of a sound. The loudness of a sound depends on the energy and intensity of the sound wave. Energy, in this case, is when you hit a drum, you hear a sound. But when you hit it harder, you hear a louder sound. That's because when you hit it harder, you transfer more energy to it, and that then creates a louder sound. So when you knock harder on a door, you transfer more energy to it, and the sound is louder. If you knock quietly, if you knock lightly, not as much energy passes through, and then there's a quieter sound. So the more energy a sound wave has, the louder it sounds. Intensity. The amount of energy a sound wave carries per second through a unit area. A sound wave of greater intensity sounds louder. The closer a sound wave is to its source, the more energy it has in a given area. So a decibel is the unit used to compare the loudness of different sounds. Okay, so it's not necessarily the measure, but the unit used to compare the loudness. So the loudness of a sound you can barely hear is about 0 decibels. And dB with a capital B is how you abbreviate that. Sorry. So a 10 decibel increase in loudness represents a 10-fold increase in the intensity of the sound. So from a 0 decibel sound to a 10 decibel sound is 10 times louder. So sounds louder than 100 decibels can cause damage to your ears, especially if you listen to those sounds for long periods of time. So let's take a look at this chart here. So we have measuring loudness. On the left you have the sound, on the right you have how many decibels it is. So the threshold of human hearing, remember that's the sound you can barely hear, is a 0. A whisper is 15 to 20. A normal conversation is 40 to 50. Busy street traffic is 60 to 70. A hairdryer is 80 to 90. A rock concert is 110 to 120. Headphones at peak volume are 120. And a jet plane at takeoff is 120 to 160. Now remember, a sound at 100 decibels for a long period of time is going to start hurting your Start hurting your hearing. So right here is where that is. So a rock concert, which is already a long period of time, is going to hurt your hearing. Headphones at peak volume, hopefully you don't listen to them at peak volume, is going to hurt your hearing. And then a jet plane at takeoff. Typically, we're not going to be hearing jet planes that close, but the people that work there do. That's why they wear like noise-canceling headphones. But also notice a hairdryer is really close. And when you use a hairdryer, if you do, you don't use it for like 2 seconds. You use it, I mean, at least I use my hairdryer when I have to for like 5 to 10 minutes. It takes me to blow dry my hair. So that's not going to be, that's not going to be a short amount of time. And if you're a hairdresser and you're using a hairdryer regularly, you're going to use it for a long period of time. So just kind of, that is pretty high still, okay? So what else do we have here? We have the Doppler effect. Is the change in frequency of a wave as its source moves in relation to an observer. The Doppler effect occurs because the motion of the source causes the waves to either get closer together or spread out. If the waves are sound waves, the change in frequency is heard as a change in pitch. So how do your headphones work? First, an electrical signal travels up a wire. Then, the electrical signal causes a magnet to vibrate. And last, the magnet is attached to a thin cone of material. The vibrating cone sends sound waves through the air. So our vocabulary, remember density is the only word from lesson 1. So density was how much matter or mass there is in a given amount of space or volume. Pitch is a description of how a sound is perceived as high or low. Loudness describes your awareness of the energy of a sound. Intensity, the amount of energy a sound wave carries per second through a unit area. Decibel, the unit used to compare the loudness of different sounds. And Doppler effect, the change in frequency of a wave as its source moves in relation to an observer. So I know that was a little more because we combined 2 lessons. That's okay. So your assignment is to complete the Edmodal questions for lessons 1 and 2. So it's combined, and there is about 20 points, I believe, on this assignment. So let me know if you have questions. Otherwise, have a happy Tuesday.